Hey everyone, so today we are also doing the polynomial and rational inequalities. Hopefully this lesson isn't very long, hopefully like 20 minutes, we'll find out. Um, it You can do it algebraically, what we're doing here, and we can also do it uh, graphically as well. So here for the objectives, solve nonlinear inequalities given a graph, and then solve polynomial and rational inequalities algebraically, so just from their equation. Uh, For the function f of x graph below, solve f of x greater than or equal to 0 and f of x being strictly less than 0. So here we're talking if like where are we? Where are we in relation to the x-axis, basically? Okay, right? Because that's what we mean in terms of greater than or less than 0, right? The x-axis is the line y equaling 0. So if I want to be greater than or equal to, that means we also include in any x-intercept. Strictly less than, I guess just strictly less than. So if I do, let's see, say in pink, greater than or equal to 0, well, that would be all of this right here, including 3, and then all of this here. So this looks like that we have I mean, we don't know what the graph is, but I would assume, or it kind of looks like we have maybe a horizontal asymptote of y equaling 0, but we don't know that. So I would just say that we are greater than 0 from -3, making sure we use a parenthesis around -3 because this is a vertical asymptote. Right? These are vertical asymptotes. And remember, we can never touch or cross. Cannot touch. So we always use a parenthesis, okay, whenever we are talking about a vertical asymptote boundary. So -3 to 3, but I'm going to use a bracket because we actually touch, I can't talk, touch the x-axis here. And then we're going to skip over union, parenthesis, 4 to infinity, because we're going to assume that we never cross. We never cross the x-axis again. So that is for f of x being greater than or equal to 0. It's a colon. In green, if I do f of x less than 0, so strictly less than 0, meaning we're not going to include any x-intercepts. So we're going to use parentheses all the time. That's this area right here. So say negative infinity to -3, again, parenthesis anyways, because it's a vertical asymptote we cannot touch. Union, and then over here from 3, parenthesis, because now strictly less than, pop that in, to 4, close parenthesis. Because again, we're going to get super close to 4, but never touch 4 itself. So parentheses around these vertical asymptotes, right here and here. Vertical asymptote. There we go. That's it. That's basically the whole lesson graphically. So if you can punch it in a graph and understand, equal to or greater than, strictly less than, that's really it. So the rest, or this next one, is now algebraically. So solving polynomial inequalities without a graph, here's kind of step by step. Get 0 on one side of the inequality. Solve f of x equaling to 0 to get the boundary point. Put the boundary points on a number line, evaluate the function at a test value at each interval, write the interval that satisfies your specific inequality. So this is also 3 and 4 is what we call a sign chart. Okay, we'll talk about that here in a hot second, but this is the sign chart. So we want to set the equation equal to 0 to get the boundary point, because again, we're talking basically where are we in reference to the x-axis or y equaling 0, right? Are we above it, below it? Where are we? What are the intercepts? All that fun stuff. So that's why we want to be set to 0. And then factor, do anything we need to so that we can get the rest. So we have example 2. Solve x squared plus 5x is less than or equal to -4. So I want to get 0 to one side. Again, I like my variable term to be positive. So I'm going to add the 4 over. So x squared plus 5x is plus 4 is strictly less than 0. Okay. So remember, we want to now know where our graph is below, because less than 0, the x-axis. This is what that means. Where is our function below the x-axis? X squared plus 5x plus 4 less than or equal to 0. This is basically what this means. So this is a quadratic. We need to be able to factor it. So we have x, 4, and 1, because 4x plus 1x is the 5x. We're now going to set it equal to 0 so that we can find the x-intercept. Using the zero product principle, the x-intercepts are at -4 and -1. So here's the sign chart. Right? We don't have the picture, but we know we have x-intercept at -4 and 1. And we'll switch colors. So we have the x and f of x, also y, right? So on our number line is going to be -4 and -1. Has to be in number order, okay? Because it's a number line, right? So it has to be in numerical order. So make sure -4 is to the left of -1. Then we're going to evaluate the function at test values in each interval. My super faves, when available, are 0 and -10, but really you can do whatever you want. So we know that these are zeros, so I like to mark them as zeros right here in the y area. So I'm going to use 0 as an x. So I'm going to pop 0 into any form of the function we want. If I do it into here, that says, well, 0 plus 0 plus 4. So that's a +4. Now, I don't care that the actual output is 4. I don't care. All I care is what the sign is. That's why we call it a sign chart. Okay, I don't call it the number chart, the sign chart. I just want to know, are we above or below the x-axis? So if I'm positive, that tells me my function is above that x-axis. Now you can choose any number between these two values for your next test point. -2, -3, -3.5, -1.5. I don't care. It's up to you. Let's do -3. So now -3 can go into any version of the function. I usually like the factored version because then I can just do multiplication of signs. So -3, because that's my random test value. You don't have to do -3. You can do -2. It's arbitrary. So -3 plus 4 is 1. So that's positive. -3 plus 1 is negative. So a positive times a negative is overall negative. Again, I don't care what the number is. I don't care. I care what the sign is because we want to know where is our graph below the x-axis. That means where is my y? Negative. Then my next favorite little Goldilocks test value number, -10. Not too big, not too small. It's just perfect. So if I pop in -10, that's a -6 times a -9, but a negative times a negative is the positive, and that's really all I care about. Okay, and there we go. So here, this is our sign chart. So now we are ready to evaluate. Since I want to know less than 0, that means I want the negative chunk. I want where are we negative. So that is from -4 to -1. Since I'm strictly less than 0, we want all parentheses all the time. And that's it. Yay, we're done. Graphically, so now just to sketch the graph, 1, 2, 3, 4. I know that the graph looks, oops, sorry, something like this. Okay. Because we know it's quadratic. So if I have x-intercepts at -1 and -4, that tells me that negative, what, 2.5 is my axis of symmetry because it's going to be right down the middle. And that I open up because I'm a bull because I am a positive x squared. So this is the answer right here, the interval from -4 to -1, because this chunk right here is where we are below the x-axis. Yay! A page here. Now we want to look at this. So I'm set to 0. However, I hate my leading term to be negative. I don't like it. It drives me nuts. So I am just going to move it over everything to the right. So 0 is less than or equal to x squared minus 3x. Okay, that's just a me thing. I don't like my leading term to be negative. This causes issues for my brain later down the road. Here, let's see. We just want to factor, right? So I'm going to set it equal to 0. Both terms have an x in common, and then our quote leftovers are x minus 3. So my zeros or x-intercepts are 0 and +3. Because here I take this term, set it equal to 0, right? So x equals 0. Take this term, set it equal to 0, so x equals 3. So now we have the sign chart. So on my sign chart, I'm going to have 0 and 3. Again, make sure they're in numerical order. So I'm going to do -10, maybe a 1, and a +10. I can't use one of my favorite Goldilocks test values, 0, because it's already chosen right here. All right, so if I pop in -10, you can do it into any version. Again, I like the factored form just because it's easier in my brain to do the positive times the positive, negative times the negative, whatever, negative times positive, positive times the negative, that fun stuff. So -10 times a -13 is a negative times a negative, which is a positive. Now 1 times a negative, -2 technically. So positive times a negative is a negative. And now 10. Positive 10 times a +7 or positive times a positive is positive. Again, we don't care what the output is. It's called a sign chart, not a number chart. That's why I'm not concerning myself with that business. Just get your sign, get in, get out, get on your way. So now, go back and look. I want, where is our value? So our value is greater than or equal to 0. So I want the positives, right? So if the alligator is eating my function, I want my function to be greater than 0, right? I'm bigger than 0. Nom, 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 nom. That is here and here. I am including the zeros. We don't have to worry about any vertical asymptotes because it's not a fraction, right? There's no rational, it's not a rational function. So the answer then is from -infinity to 0 bracket union bracket 3 to +infinity. Yay! Again, always parentheses around infinity because it's an idea and actually we can't ever reach it or touch it. And brackets around 0 and 3 because we have the or equal to, right? We have the or equal to. That's it really. So I want you to pause the video and do example 4. Pause the video and try example 4. Okay, so you paused, maybe you didn't, who knows? Here we go. We like 4 because it's already in factored form. So the zero product principle says that I have a zero at 0 and +4. So those are my two numbers that go on our sign chart. So X, Y, let's go with 1, maybe -10, maybe +10. Ooh, so pretty. Ooh, what nice numbers. Ooh. So -10, well, negative squared is positive. That would be -14. So a positive times a negative is a negative. Now if we pop in 1, 1 times a negative is also negative. Oh, these are zeros. Let me mark them as such. So now if I choose +10, that's positive times a positive, because that's technically 100 times what, 6? So positive times a positive is a positive. Ooh, and look, here, fun stuff, we're layering what we learned. This is so exciting. No, you might not find it exciting, but I find it exciting. So we have zeros of 0 and 4. Look at their multiplicities. The zero's multiplicity is 2, which means that we cross. That's what you mean, which means that we touch at that x-intercept. The 4 has the invisible multiplicity of 1, which is odd, which means that we cross at that x-intercept. And look, we have negative, negative because we just touch or bounce at the 0 of 0. Thanks, sir. Layering, and it's so fun. Okay, so essentially what this could look like, this is a cubic. Here's my 0, here's 4. It might look something like this, right? I know it's below because we did our test values of negative. Here is 4, our other 0, and we're positive. And that's so cool. Look, so the multiplicities tell us what behavior is at the x-intercept. So if you know, if you feel comfortable with multiplicities and what they tell us about the behavior of the x-intercept, you really only have to do one test value. Because after this point, you just go by the multiplicity. So if this is negative, this is multiplicity of 2, which means I'm going to touch or bounce. So negative, negative. 4 has an odd multiplicity of 1, meaning I have to cross. Meaning if it's negative to the left, it has to cross to positive on the right. Okay, but I know, I'll move on. So this again says, where is our function greater than or equal to 0? So we just want this little section right here. That is bracket 4 to infinity. That's it. Ta-da! If you have a graphing calculator, you're more than welcome to just plop this sucker in there. X squared times x minus 4, and then graph. It graphs, it graphs. And ta-da! See, you can do it that way as well. Totally fine if you have a graphing calculator to do it this way, because I'm just, evaluating you or testing you over, do you know what this thing means? If you do it algebraically or with the calculator, that's fine, because you're still showing me you know what this means. You can even do it this way, okay? So if I flip the sign to make it mirror what I solved for, x squared minus 3x, and we graph, where is this greater than or equal to 0? Look, to the left of 0, to the right of 3. So basically just getting rid of this middle portion. Again, if you want to do it graphically, I don't care, go crazy. Say you're not sure what the zeros are, you go second, calc, 0, because that's what the x-intercept is called, right? A 0. Move your cursor to the left, enter. Move your cursor to the right, enter, enter, it's 0. So if I want to do the other one, second calc, 2 for 0, move your cursor to the left bound, enter, right bound, enter, enter, and there, look, 3. Can you see that? 3. That's it. If you want to do it this way, by all means, I don't care. Go crazy. All right, that's all we have time for. We'll do the last page in class. All right, let's see if I can stop this recording. I'm never really quick at this. Forgive me. Okay, and goodbye.